Dear student, yesterday we have had a discussion on oxide layer. As all of you know that once an oxide layer is formed on the metallic surface, further prospect in terms of oxidation will be decided by metal oxide, and because of that it was very much important for all of us to know the type and nature of oxide layer. And we have seen that oxide layer may be of 4 types, and they were stable, unstable, volatile and porous. So yesterday we had a detailed discussion on stable oxide, and today we will be talking on the remaining 3 oxides. Number 2. It will be your unstable. What does it mean? Suppose you have made a metallic structure made of silver. Oxygen is there in the environment. It will be attacked and silver oxide will be formed. Silver plus oxygen is H2O. It will form a reversible reaction. It means the moment silver oxide is formed, it is decomposed to silver and oxygen again. What does it mean? It means your oxide is unstable, as a result of which net corrosion will be 0. Most common example is the oxidation of noble metal like gold, silver, platinum. This is all about your unstable oxide. Now, third one is your volatile oxide. This is very, very important. Suppose you have made a metallic structure made of molybdenum. We know that if it is attacked by oxygen, what will happen? It will form MoO3. This is your oxide layer. Now let us see. Here I would like to give one example. You might have seen in the urinal we generally use naphthalene ball. Today, if you put a bigger ball in your urinal, after 7 days, if you carefully observe, you will see the size of the ball has got reduced. And after 15 or 20 days, it will be disappeared completely. So similarly, if the oxide layer that is formed here, molybdenum oxide, it is volatile in nature. It will go off after it is being produced. What does it mean? As a result of which, the entire metallic structure will be exposed to the environment for further attack. And again, molybdenum oxide layer will be formed. Again it will go off. And this process will be continued so long the entire metallic structure is not being destroyed. And therefore, we can conclude here, if the oxide layer is volatile in nature, it will go off after it is formed, exposing the metallic structure for further attack, as a result of which this process of that is formation and going off will continue till the entire metallic structure is being destroyed. And now the fourth one is, if your oxide layer is porous in nature. You understand pores. Let us take an example. Suppose it is a metallic structure made of iron. We all know that in an environment it will be attacked by oxygen and oxide layer will be formed made of ferrous oxide. Now, ferrous oxide being porous, there will be many pores or holes on the surface of the metallic oxide, as a result of which oxygen can go in, metal ion can go out, and the process of corrosion will be continued until and unless the entire metallic structure is not being destroyed. This is all about your nature of oxide layer. Before I move further, I would like to summarize that oxide layer may be 4 types. Number 1 was stable, second one is unstable, number 3 is volatile, and number 4 is porous. Now, in this context, there is a famous rule proposed by 2 scientists, Piling and Bedworth. And according to them, I am writing first and then I will be explaining. An oxide layer will be non-porous, that is protective, only if volume of oxide layer is at least as great as the volume of metal on which it is formed. This is the Piling-Bedworth rule. The rule says an oxide layer will be non-porous. Non-porous means protective. There will be no pores, and therefore rate of corrosion will be reduced and ultimately it will be stopped. And porous matlab, what do you mean by porous? Pores will be there and further corrosion will proceed. And you must remember, if the oxide layer is non-porous, it means it is protective. It will protect the metallic structure from further attack. And if it is porous, it is non-protective. It is unable to protect the metal from incoming attack. Now, according to the Piling-Bedworth rule, Piling-Bedworth rule, an oxide layer will be non-porous, that is protective, only if volume of oxide layer is at least as great as the volume of metal on which it is formed. Let us take one simple example. Try to understand that. And if you understand that, my purpose will be served. Take some soil, mix a little bit of water, and make it semi-solid kind of things. Now taking some of them, put a layer on your hand of the soil. Keep it on sunshine. After some time it will be dried. Then if you carefully observe, you will see something. What you will see? There will be millions of cracks. Then put another layer onto it. Get it sun-dried again. And if you look at it, you will definitely find cracks over there, but it will be definitely less than what you have seen for the first time. And if you continue doing like that, one time will come when there will be no crack. And in this process, the thickness of the layer which you were applying on your hand will be this much. What does it mean? When it has become crack-free, when the thickness of this layer has got up tremendously. So similarly, they are telling that, suppose it is a metallic structure, they are telling that if this is the oxide layer, this layer will be protective, that is not porous, only if volume of this is at least equal, if not more, than the metallic surface on which it is formed. So what example I have given few minutes back, exactly in the same line. To have a protective film, the thickness of the film, thickness of the oxide layer should be minimum equal to the volume of the metallic surface on which it is formed. This famous rule was proposed by Piling and Bedworth. And therefore, alkali or alkaline earth metal, whenever they make oxide film, volume of the oxide layer will be definitely less the volume of the metal on which it is formed, and therefore those oxide films or layers comes under tremendous stress, as a result of which there will be huge number of cracks. Through these cracks, corrosion will be continued. But in case of metal like aluminium, the thickness of aluminium will be minimum equals to the volume of aluminium on which it is formed, and therefore there will be no stress, there will be no crack, and ultimately corrosion will be stopped. This is what we have seen so far. Now one more thing I would like to tell today in this context, that is Piling Bedworth Rule, Piling Bedworth ratio, Piling Bedworth ratio. Sometimes you may find it PB ratio. It is actually Piling Bedworth ratio. In fact, the ratio between the volume of metal loss. Try to understand, when a metallic oxide is formed, ultimately it will go out in the form of scale or film, there will be loss of metal. And therefore, the ratio between metal loss and the volume of the metal oxide formed is known as PB ratio. For example, we can tell that for magnetite, Fe3O4, formula of magnetite is Fe3O4. PB ratio is 2.1. By using this, we can find out the volume of oxide layer. As all of you know that the volume of oxide layer can be calculated by multiplying the volume of metal loss by PB ratio. I repeat, what will be the volume of the metallic oxide that is formed on a particular metallic surface? You can calculate by multiplying the volume of the metal lost during the process of oxidation by PB ratio. This is all about of today's lecture. I am confident that you will go through the video very carefully, and this is all about your oxidation due to oxygen. In our next lecture, we will start talking on oxidation due to other gases and liquid metal corrosion.